Stationary points, maximum and minimum.
Hello and welcome to this session. Today we are going to discuss about stationary point. What is a stationary point? How we can find out maxima and minima of a function. So when we say the stationary point, that means at that particular point the function is not either increasing or decreasing. That means the slope of that point at that particular point, the slope of the graph of the function will be 0. Or in another word, what we can say stationary point of a function is a point where the derivative of a function, if it is equals to 0, or it can be, then that time it can be either maximum or minimum, then we can say that point is stationary point. Now let's try to understand using the graph. Like suppose if I try to draw a graph like this one. So at particular this point, if I'll see, and this point and this point, these are the 3 points where if I try to draw a line which is a tangent, right? In this case, if you see that this tangent is parallel to the x-axis, that means whenever the tangent is parallel to the x-axis, that time the slope or the gradient of the function will be 0 at that particular point. So this point are nothing but the stationary point. Okay, so this function we can say this is stationary point, this is a is a stationary point, b is a stationary point, and c is a stationary point. Okay, now a and c, if you see, it is maximum. Why? Because it is the maximum value. The graph is going maximum for a and c and the minimum for this one. Okay, so whenever we have to identify the stationary point, that means the gradient or the slope at that particular point will be 0. Okay, but for a function, how we can find a gradient? So for a function we can find the gradient by using this method, dy by dx. That means if a function is y is given and if we have to differentiate this function with respect to x, whatever the value we'll get it, if we'll equate it to the 0, that time we can say this is the stationary point. Okay, now so let's do this question. Find the coordinate of 3 stationary point on this curve. So this is one equation is given. Now how we can find the dy by dx? Okay, so dy by dx, if like suppose if there is any function x raised to power n, and if I have to identify derivative of this function, then this is algebraic function, and for this question also this is algebraic function. What we can write here, n into x raised to power n minus 1. Example, if I have a question like x raised to power 4 like this way, so we can write here 4 into x raised to power 4 minus 3, which is 3. So this will be our derivative. So let's start and solve this question. We will identify the stationary point. Using the stationary point, then we will try to understand what is maxima or minimum of the function. Okay, so a stationary point is now fine with us. Now we know if we have to identify the stationary point, first step we have to solve the equation, or we have to differentiate the given function. So y is equals to, I am going to differentiate is, question is 1 upon 4 x raised to power 4 minus 3x cube plus 9x squared. Now first step, differentiate. Okay, so differentiate with respect to x. I am going to differentiate this function with respect to x, so I am going to write a dy by dx is equals to 1 upon 4 is a constant, I will leave as it. So if there is any like if there is a question like a into x raised to power n, a will come outside because this is constant. Okay, if there is a only without any variable, like if I say this is a is like 1 2 3 any constant value, that time the direct derivative of this function will be 0. So here 1 upon 4 I will leave, because using this rule I will write here a x raised to power n minus 1, a n into x raised to power n minus 1. So a is done. Now x raised to power 4, I will use this one, or I can use this one. So I will write here 4 x raised to power 4 minus 1, which is 3. Now again minus sign 3, I am going to write here 3 Now x cube, so I will write here 3 into x raised to power n into x raised to power n minus 1, 3 minus 1, which is going to be 2, plus 9, again I will write 2 into x raised to power 2 minus 1, which is going to be 1. I will try to solve this, and this got cancelled, right? So I cancelled it. So dy by dx, our next step will be x cube minus 3 into 3, 9x square, plus 9 into 8, 9 into 2 is 18, sorry, 18x. So now this is our dy by dx. So whenever we have to find out the stationary point, this dy by dx should equals to 0. This is nothing but the gradient, right? So we have to find out the value of the gradient. So what I will do, I will substitute 0 is equals to dy by dx is 0, x cube minus 9x square plus 18x. Now if you'll see here, this is related to the factorization, which we already did a video in the for the previous session, so you can check there how we can factorize this one. If you see x, x and x, which is common for all three terms, I am going to take common x. There will be x square minus 9x plus 18. Okay, now if the product of two function is 0, that means we can say either x will be 0 or x square minus 9x plus 18x is equals to 0. Now this is a quadratic function or quadratic equation, we can say, because there is equals to 0. If you see, we can use here middle term factorization. For the middle term factorization, we already have one session, and there is a video I uploaded it. You can go through that video. So here, like what we have to do, like first into last, which is 18 x square or 18, I'm going to write here. Now what are the factor of 18? 9 into 2, 18 into 1 and 6 into 3. These are the factor. Okay, if you see the middle term is minus sign, that means either of them should be one negative. 9 minus 2, which is going to be 7, not this is not, we cannot consider, this is also we cannot consider. Minus 6 minus 3 is minus 9, and minus 3 into minus 6 is plus 18. So this is our middle term. So in this scenario, I am going to write an x square minus 6x minus 3x plus 18 is equals to 0. Make the grouping. Once you complete this middle term factorization, then you have to make the grouping of these two. X I will take common from the first term, so x minus 6. 3 I will take common, so x minus 6. If you'll see, these two values are equal, that means we are on the correct path. So x minus 6, x minus 3 is equals to 0. That means either of them will be equal to 0. So x minus 6 is equals to 0. That means x is equals to 6, and similarly x is equals to 3. So we have now 3 point which we got it from the, for the x is equals to 0, then 3 and then 6. So we have to find out the respective value of y in order to complete this question. So first part is done, 0, then 3 and then 6. Okay, now what is our question? If you'll see here, question was 1 upon 4. So I'm going to write here y is equals to 1 upon 4 x raised to power 4 minus 3x cube plus 9x square. 3x cube plus 9x square. Okay, so when x is equals to 0, okay, so what will be the respective value of y? 0 raised to power 4 is 0, 0 into anything is 0, minus 3 into 0 is 0, and plus 0, so answer is 0. First value we got it 0 comma 0. So when x is 0, then y is 0. Now let's put the value of 3 and you'll get the value of y when x is equals to 3. So 1 upon 4, 3 raised to power 4 minus 3 into 3 raised to power 3 plus 9 into 3 raised to power 2. Okay, so let's try to solve this one. 3 raised to power 4, which is nothing but 81, divide by 4 minus 3 raised to power 3 is 27, 3 into 3 into 3, 27 into 3 is 81, plus 3 into 3 9, 3 into raised to power 2 is 3, into 3 9, 9 into 9 is 81. Again we can cancel this one. Our answer is 81 upon 4. If we'll try to divide this one, how much value we will get it? 20.25. So another value we got it. Now for the third one, right? Try to substitute for third one. Y when x is equals to 6. 1 upon 4, 6 raised to power 4 minus 3 into 6 raised to power 3 plus 9 into 6 raised to power 2. So 6 raised to power 4, 6 into 6, 36, 36 into 6. If I will multiply it, 6 into 6 into 6 into 6. 6 into 6, 36, 36 into 6, 216. If I multiply 6 into 6, 1296. So I will write here 1296 divided by 4 minus 6 raised to power 3. Again 216. So 216 into 3 plus 636 into 9. Okay, let's divide this 4 into 3, 12, 4 into 2, 8, 4 into 4. So 324 minus 3 into 6, 8, 48, 3 into 2, 6, 48 plus 9, 6 into 54, 6, 90. Okay, so this is again 324. So now our answer is 648 minus 648, which is going to be 0. So now we got the coordinate of all the values, which I am going to write is 0, 0, 3, 20.25 and 6, 0. So this is how we can find the stationary point by differentiating the given function, then equate it to the 0. From there we can identify the value of x, and if we'll substitute back in the given equation, then we can find out the respective value of y. Now moving to the maxima or minima. So if you see, like I told you, right, if dy by dx is 0, then that this point and this point, these can be maxima or minima, but how we can identify? So from the graph we can see, okay, A and C is maxima, B is minima. But if the given question is there in terms of function, how we can identify? So whatever you differentiate it, right, the first differentiation you got it x cube minus 9x square plus 18x. If you will differentiate second time with respect to x, okay, if you will differentiate this one, and if you are going that particular point, like suppose you got the stationary point x is equals to a, and that time if it is greater than 0 at x is equals to a, we can say it is a minimum. Okay, so this is what minimum. And if d2y by dx square is less than 0 at x is equals to a, then we can say maximum. Okay, so for minima and maxima, again we have to differentiate the given equation. So dy by dx is x cube. I am going to write here dy by dx is equals to x cube 9x square plus 18x. Okay, 9x square plus 18x minus 9x square plus 18x. Again we have to differentiate it. So d2y by dx square with respect to x. So x cube, x is to power n, that means 3x square 9. So 9 2x is to power 1 plus 18x. There differentiation of, if there is x, then that is always 1. So 18 into 1. So our double differentiation is now 3x square minus 18x plus 18. Okay, now we got the 3 point, right? One was 0, one was 3, another was 6. These are the values of a stationary point x, x and x. I will try to find out d2y by dx square when x is equals to 0. If I'll put it here, 0 square into 3 0 minus 18 into 0 is 0 plus 18. I got the value which is greater than 0, right? That means minimum. So at x is equals to 0, this value will be minimum. Okay, now similarly, if d2y by dx square we have to identify for x is equals to 3, then we can 3 into 3 square minus 18 into 3 plus 18. Solve it. 3 into 3, 9, 9 into 27 minus 54 plus 18. If I'll try to add it, 27 plus 18 is 45 minus 54, which is minus 9, less than 0, maximum. Since it is what? Less than 0, at x is equals to 3, it will be maximum. Now third one, d2y by dx square when x is equals to 6. So 3 into 6 square minus 18 into 6 plus 18. Okay, so if I'll try to solve this 6 square 36 into 3. 36 into 3 is 108 minus 18 into 6 is 108 plus 18. This and this got cancelled, greater than 0, that means minimum. So this is how we can find the maxima and minima for the question to determine whether each stationary point is a minimum or maximum, and then you have to identify. So for 0 it was a maxima, rest of the two cases we can see here we got for 0 it was greater than 0, so minimum, less than 0 for 3 then a maximum, and greater than 0 then it is a minimum. So thank you for watching. Okay, thanks.